Hey there, in this video we're talking about inheritance in C++ object-oriented programming, and this covers sections 15.1 to 15.5 in the Gaddis textbook. And yeah, inheritance, boy, what a huge, important subject this is in object-oriented programming. This is like one of the 2 or 3 most powerful tools that you have in object-oriented programming. And to make a long story short, you can very quickly build out new classes based on old classes that you already have in your system. So definitely let's look at this. Okay, what is inheritance? So this is providing a way to create a new class from an existing class. And when you do this, your new class is going to be a specialized version of the existing class. It's kind of like the old class with extra features added. And what specifically happens is your new class is going to inherit all the member data, all the variables, and all the member functions from the old class. You're going to get all that stuff for free. And then you can also add other new members as well. You can add other new member variables, new member functions if you want to, but you get all the stuff from the old class for free. Now, as just a little side point before we get into details here is, the subject of chapter 15 in its entirety is inheritance and polymorphism. And so in the next lecture, we'll see what polymorphism means, but the two things work very, very closely together. So in addition to just building out new classes, we're also setting ourselves up for polymorphism in the next video. So keep that in mind, but for now we're focused on how can I build new classes very easily. Now, think about this. Conceptually, what you're doing is you're building objects that have an is-a relationship. Inheritance establishes a grammatical is-a relationship between classes. For example, you could say this: a poodle is a dog. That's a true statement, okay? And kind of what I would want to say myself is I'd want to say a poodle is a special type of dog. And other examples here out of the book, a car is a vehicle. Yeah, a car is one type of vehicle. I mean, there's also trucks and bicycles and things, buses and things like that. But yeah, a car is a vehicle, no doubt about it. A flower is one kind of plant. A football player is one type of athlete, sure. So what they're saying here is, if you remember back to your math classes, we're saying something very similar to a subset relationship. An inherited class is really a subset of the larger class. So each of these things here, we're really talking about subsets. But grammatically, you could say each of these first things is a version of one of these second things. And that grammatical concept is going to be really, really important in the next lecture when we talk about polymorphism. It's going to be a very important mental construct about, is item A, is it a type of item B? And if so, then it's going to work very nicely for us. So just think, reflect. These are big topics. These are big issues that we're bringing up in these videos in chapter 15. So they're things you're really going to want to think about and reflect and meditate on for kind of a long time, and they're really going to change how you think about programming and how you think about object-oriented programming. But just for starters, make sure that you can just digest this. The classes that we're making represent objects that are specialized type of another category, okay? Just like subsets. Okay, so here's the specific. If you want to do this, here's how you make that happen. And also a little bit of terminology here. So the original class that you're starting with is referred to as the base class, to be official about it, or some people call it the parent class. That's what we're inheriting from. And then the new class that you're making is referred to as the derived class, or maybe the child class, some people would say. I usually go back and forth between either of these names. That's the class that you're inheriting. You're inheriting all the stuff from the base class. So that's going to look like, maybe I have an original class called student. We've seen that in the past. Okay, so our base class, and it's got private and public sections, and it's got member data, and it's got public functions, of course. Okay, and now we're making a specialized version of this. We're making a new class called undergrad to represent undergraduate students, as opposed to graduate students in a PhD program or something like that. Now, here comes a colon, and here comes the class that we're basing it on. We're stating what is my parent class, and the parent class is going to be student. Notice right here is what's called the class access specifier. So there's a little code here saying that anything from student, basically this is setting the minimum security level. Okay, so at minimum, the functions from student have an access of at least public. We'll talk more about that on the next slide. But anyway, having done this, okay, the undergrad class automatically has everything from the student class, all the member variables, all the member functions, both public and private and anything else. And now, in these curly braces, you can add more stuff if you want. And that's what it looks like when you're making an inherited class. Okay, so as you can see here, the one little detail here is what is the access from the parent class versus access in the child class. So obviously the stuff in the student class is either public or private. And also remember there's a third one, protected. And then what is the access of that stuff when it shows up in the child class? And this class access specifier is kind of a key that's controlling that. Let's talk about that. Okay, now first of all, what is the access in the inherited members in your new class? Now first of all, members that are private in the parent class are totally inaccessible in the child class. And hopefully that makes sense. That's the whole point of private. We said private means here's a piece of data in a class that you can access in that class and nowhere else. No exceptions. So if you make it private in the parent class, you can't access it anywhere else, including its own children. And that's what I would expect, frankly. So that's what happens there. Now, remember, here's that third thing. If you don't like that, right, if you don't like the fact that the member data that was private in the parent is now inaccessible in your child, you could make it protected instead, back in the parent class. That's what the protected access specifier is for. You make it protected in the parent class, and then all that data is accessible in both the parent and the child class, but inaccessible in other code. Okay, so it's kind of like private, with the exception of you can also access it in the child classes from this parent. So just a little bit more generous, right? Can't access it in the main function, can't access it in other classes, but you are allowed to access that kind of data in the child classes. It's protected. Okay, just a little bit more generous than private. Now, other than that, again, you have other things that are, maybe public or protected or something like that. So other than that, the class access specifier that we've kind of highlighted in the prior slide is establishing a minimum security level for any member access specifiers in your child class. And the book kind of goes into details about that. So if you make your class access specifier public, it means that your child class functions could be up to public access, right? Which is very generous. So all the public stuff from the child, from the parent, is also public in the child. And all the protected stuff in the parent is also protected in the child. Doesn't make any difference, okay? No changes in the access from parent to child. But if you make the class access specifier protected, then everything's at least protected, if not more secure than that. So stuff that was public in the parent is now protected in the child. And stuff that was protected in the parent is now protected in the child as well, okay? But if you make that class access specifier private, now everything all becomes more locked down. It all becomes private. Public in the parent class is now private in the child. And protected in the parent class is now private in the child as well. It's all locked down more. Of course, stuff that was private in the parent is always totally inaccessible no matter what. There's no exception to that. So generally speaking, we're not going to worry about that too much in our class, in our course. I'm just going to make the class access specifier public all the time so that whatever it was in the parent is going to be the same in the child. Good enough. Now, if you're working in a professional environment, there might be reasons to lock stuff down and be more secure about it. But at least in our course, I'm just going to make the class access specifier public. Now, we do have to pay attention to that because if you leave it out entirely, everything just became private. So the default, you don't put anything there, is actually to make everything private in your child class. And then that's probably going to be a problem for your application programmer because you just lost all access to all your accessors and your mutators, and you just lost access to all the functions because it all became private. And now the application programmers don't actually have capability of using any of that stuff. That's probably not what you want. So I'll be making all of our class access specifiers public. right? A little bit of a detail there. Not going to worry about that too much. The book goes into great detail about it, but that's what's happening there. Okay, let's see, constructors and destructors, right? So obviously your base class has constructors and destructors, I'm sure. Well, derived classes can also have their own constructors and destructors. So, and what happens there is when an object of a derived class is created, the base class's constructor is executed first, followed by the derived class's constructor. Again, this happens automatically in C++. You don't have any control over that, but it makes sense. Because if you think about the inheritance situation, like you're building new stuff on top of some kind of original foundation, right? Your parent class is the foundation. That has all the basic stuff, all the basic members, and presumably the constructor sets up the basic members properly. So obviously the base class constructor should happen first to set up all the basic stuff. Then, you're adding this new thing. You're adding this new derived class that maybe has new member data added. So then it makes sense, once the foundation's there, for your derived class constructor to come through and initialize all your added member data. Definitely makes sense like that. Now, at the end of this slide, you can see here, when an object gets destroyed, it gets removed in the opposite direction. So the stuff that got added in your derived class, the destructor is going to remove that stuff, maybe if there's dynamically allocated memory or an open file or something like that. And then, after that's gone, then the base class destructor comes through and removes all the stuff in the foundation from the basic stuff in the base class. So hopefully that makes sense. It seems to me like that's the way that would have to work, since we're kind of building on top of our base class. And that's what happens in C++, and it just automatically occurs. So I'm glad it works like that. Now, when you're working in your child class, remember your base class might have more than one constructor. We totally saw that. Like in our rectangle class, we had a constructor that took no arguments, took one argument, took two arguments. Seen that a couple times. So overloaded constructors, pretty common. Well, if I'm working in my child class and I'm making a constructor, I might need to pick which one of those overloaded constructors from the base class needs to run. So I might need to make the decision about how I want to initialize the original member data back in the parent class. So you have that capacity as the programmer. You can select specifically which base class constructor you want to run as you're building your new derived object. So here's what that looks like in C++. And this is new. This is different. It's not going to look like stuff you've seen before. So what you do is you specify the arguments to your base constructor on your child constructor heading. So just for argument's sake, let's say I want to make a class called square. Now, a square is a special type of rectangle. Every square is a rectangle. You already know that. Squares are subsets of rectangles. So it would make sense to make the square class a child class inheriting from rectangle. Rectangles have a length and the width. We've already seen that before. We have a class that has a constructor, multiple constructors, accessors, mutators, computes the area, right? That's already built into the rectangle class. So what you could do here is you could make a class called square, and you'd say you'd have to write class square, right, colon, public rectangle at the top of your class to make that happen. Now you're inheriting from rectangle. And as I build the constructor to my square class, it's going to look like this on this slide here. I'd put square, that's the name of my class, scope resolution operator, square, that's the name of my constructor. Now for a square, you only have to give one single number because it's the same side all the way around the square, obviously. So one number comes in. Now as the square gets built, the first thing I want to do is call, you see there's a colon here, or this is really all one line in a standard code file, just colon. I want to set up the members to the rectangle that I'm basing this on. So what this does is it calls the rectangle constructor, and I guess the decision we're making here is to call the rectangle constructor that takes two members, takes two arguments. And what I'm doing here, if you remember, what it really is doing is it's taking in a number for the length and a number for the width. And what I'm doing here is whatever is coming into my square constructor being called side, I'm passing that in twice. I'm going to set the length to this side number, and I'm going to set the width to this side number. And that's what I'm passing in for the two arguments to rectangle. And so the rectangle length and width stores that by virtue of how the rectangle constructor works. And then if there's something else I want to do with my square, I could then have curly braces and add extra code for my square constructor. But before that stuff happens, here I am calling the rectangle constructor to set up the basic information about the length and the width as I want to. So that's what that looks like. Calling the base class constructor of my choice, because I could have called the default one, but it's probably easier to do this. You can do that inline, works the same way. You've got to do this if your base class has no default constructor. If you leave that bit out after the colon, again, there's always a constructor that runs. You don't have any choice about that. If you leave that out entirely, it's going to call the default constructor on the base class, the one that has no arguments. But if you didn't give the base class that, then you've got to specify some kind of constructor here, and then this is actually mandatory. But if you have a default constructor, this is now optional because it would just run that instead. Okay, so that's what that looks like. Totally new. But usually our inherited classes have that little piece of syntax in their constructors. Okay, what else can you do? What else can you do? As you make a new child class, how else can you modify the things? Well, you also have the option, in addition to adding more member data and adding more member functions, you also have the option of redefining functions that were in the base class to do new jobs. This is called redefining. Redefining a function. That's a function in a derived class that has the same name and parameter list as a function in the base class. Now, previously, like even in first semester, we were talking about overloading functions. We've also talked about overloading operators recently. But overloading functions normally is where you use the same name of a function, but different parameter lists. And that's how the compiler tells the difference between these different iterations of the same function. Now, this is a little bit more refined because the functions here will have the exact same signature, the exact same name, and the exact parameter list from the base class, but yet still we're going to have two different versions of that function depending in which class you're operating in. And typically we use this redefining idea to replace. You're totally replacing a function from the base class with different actions that are more specific to the derived class. So just for starters, let's say I have an insect parent class and I've got a function called, travel, okay? And the base class assumes that the insect is walking, but then if I make a child class to represent one insect, maybe in a simulator or something like that, called mosquito, well, mosquitoes fly, and I could modify the travel function to now be doing flying instead of walking, is what I could do. So that's the kind of thing we do with inheritance. Let's see an example out of the book that kind of puts all this stuff together. So here's a base class called graded activity. And the book has kind of a fairly large example because you have multiple classes interacting here. So they're going to make a parent class called graded activity, and this category includes anything that happens in a college course that grades get received for. So graded activity, anything with a grade. So here is your member data, just one piece of data here, a double variable called score to hold the numeric score for this particular assignment or test or quiz or whatever. Now you notice that up until now, we've always made our data private, but here for the first time, we're making it protected because presumably we're going to make a child class. We're kind of thinking ahead here. We're going to make a child class, and that child class has to have access to that score. So we've made it protected so that that cannot be accessed by anything else in the code except for child classes. So that's what that looks like. Now the public functions, of course, you get a constructor. Here's a default constructor, just got scored to 0 to begin with. Here's a constructor that does take one argument, right, that sets up the score to this number initially, great. Here's a mutator that does what mutators do. In comes a number S, you're going to set that to the score. Here's an accessor that does the normal thing, right, just returns the score as a double, set it to const because it's not changing the object at all. And then here at the bottom is maybe the more interesting function here, a function called getLetterGrade, that is going to look at your score, 75 or 80 or 92 or whatever, right? And that returns a character for what letter grade that represents, A, B, C, D, or F. Okay, so kind of keep an eye on that. That's actually the thing that's kind of more interesting than anything else here. So this get letter grade function, and we're going to see the code of that in a little bit, but basically there is an if statement that looks at what's my score, return an A, B, C, D, or F as appropriate. Okay, so get letter grade, that's what the parent graded activity does. Okay, now we're going to look at a child class. So here, we're deriving a new class based on that. It's called pass-fail activity. And sometimes in the past, in some of my courses, I have had quizzes or very short in-class assignments that I just grade on pass-fail, P or F. So pass-fail activity. Now, we're going to derive that from the graded activity class. So since a pass-fail, is a pass-fail activity a type of graded activity? Well, yes. A pass-fail activity is a graded activity. It definitely has a grade on it. Sure. So this makes sense conceptually to derive our new class based on that graded activity class. And you can see, again, we're using the public class access specifier. So all those public functions in the parent class are included in our class, and they all still have public access for us. And all the stuff that was protected is still protected here. So none of the access is changing from the stuff that we're inheriting. Now, here is some data being declared for a pass-fail activity. It's called min passing score, for the minimum passing score, the lowest score that we'll accept for a pass grade on this pass-fail activity. Notice again, this is made protected because maybe we're going to derive some more child classes. You can have multiple chains of this. Actually, there is a child class of this that they continue expanding the inheritance on, actually. But just for now, we're just focused on this. Now, at this point, with my students, like if I'm in class, I usually ask the following question. This pass-fail activity class, how many member variables does it have? Can you tell me that? How many member variables does a pass-fail activity have? And the answer is, or if you follow what we're saying here in this lecture, 2. It's got 2. It's got the min passing score, but then it also has the score variable that's inheriting from the graded activity class. Again, you get all the member variables from the parent for free, and you get all the member functions from the parent for free as well. You're not going to see it here. Why bother, right? You don't need to retype it, but you do get all that stuff for free just based on this line 5, the fact that I'm inheriting from graded activity. That's what it means. I get all that other stuff for free. And on this slide, we're just adding more stuff to the pass-fail activity. So 2 pieces of member data. Now here, I've got the default constructor for pass-fail activity. Remember, all the public functions in graded activity are automatically part of this class, and we're just adding more functions as well. So we're adding a constructor for the pass-fail activity, and you can see what constructors look like. Here's the colon, which says, as I boot this up, go call the graded activity default constructor first. And if I recall, graded activities constructor sets up the score to be 0, so it's not initialized garbage data. And then once that happens, then we come through and we set up this new min passing score to also be 0. Okay, and then here's a constructor that takes one single number for min passing score. So you come in here, someone sets up the min passing score again, colon. You're going to call the graded activities constructor first, which of course sets score to 0, sets up all the old stuff. And then after that happens, then we're going to set our min passing score to whatever number is being passed in. Great. Now we have a mutator for our MPS number, our min passing score. It does the normal thing. We have an accessor for min passing score, of course, just looks it up and returns it. Now don't forget, we also have the score member data from graded activity. We have the get score accessor. We still have that. We have the set score mutator. We get all that stuff for free. Don't forget about that. All that stuff is still public. And then finally, we have a function called get letter grade. Now remember, that's being redefined. That's the exact same name and the exact same parameter list as get letter grade that we saw in graded activity. So here's a good example of this function that's getting redefined to do a different job from graded activity. Exact same function name, but doing a different job for our specialized class. Okay, we'll just keep an eye on that. Let's take a look at that. So on the next slide, we're going to see the implementation of that function in the 2 different classes. Here's our redefined function. So when you implement get letter grade in the base class, so it's graded activity, : get letter grade, right? You're going to get this letter grade. Again, the point of the graded activity class is to grade stuff as either A, B, C, D, or F. So the way they've got this set up here is if the score is greater than 89%, the letter grade is going to be character A. And if it's not that high, then if the score is at least greater than 79, you get the letter grade of B, and so on and so forth. You see that. You're going to get either A, B, C, D, or F as appropriate, and you return that letter. Now here's the version over here on the right. Here's the version of get letter grade in the pass-fail activity class. And of course, for a pass-fail activity, you should not be returning a grade of A, B, C, D, or F. You should be returning P or F for pass or fail. And that's exactly what happens here. So you get in here, you have a local variable again. You check if the score is greater than or equal to the min passing score that we've recorded, then your letter grade is going to be P for passing. Otherwise, I guess the grade is going to be F for failing, and you return that. So two different versions of the same function. Get letter grade in the base class returns either A, B, C, D, or F, but get letter grade in the derived class returns either P or F, and that's what you want. So really good example of redefining a function to do a more specific job for your child class. But that's not the end of the story. So the book actually continues to build out this example with more child classes than we've seen so far. What we're seeing here for an illustration here is what's called a UML, Unified Modeling Language, class hierarchy diagram that shows the relationships in parent and child classes. So we've seen here the graded activity, which is the parent class. We saw the pass-fail activity, which is the child class. There's another child class of graded activity called final exam, just to handle final exam type questions. And then pass-fail activity itself has another child class called pass-fail exam. That's even more specialized, an exam that you only get a P or F grade for. So that makes sense to inherit from that. So you can make child classes of child classes of child classes, sometimes chains together more than that. You can see that in the UML class diagram, the relationship is indicated with a triangle arrow. So pass-fail exam is inheriting from pass-fail activity, and pass-fail activity is inheriting from graded activity. And I think the book even adds another one at some point beyond that. So kind of interesting, if you do have access to the Gaddis textbook, a nice continuing example of all these classes all interacting together, built one on top of the other. And of course, that's quite a bit of code. It's quite a bit of page count there if you look at the whole thing. We want a technique for communicating the relationships very quickly and easily, and that's what this UML class hierarchy diagram gives us. And then you can dig more into the details about each individual class. Now remember, what I might call now this grandparent class graded activity, it's got a score member, it's got a get score accessor, it's got a set score mutator, and every single one of these classes in this picture all have the same stuff, right? So you can take for granted that every single class has a get score accessor and a set score mutator. They all have it because they're all inheriting all the stuff from the graded activity, and you're adding more specialized stuff as you go down the chain. So we do this quite a lot. We do this quite a lot in object-oriented programming. Gives us a lot of flexibility, gives us a lot of power for quickly building out more classes. And again, when we come back for the next video on polymorphism, this sets things up very, very nicely for very convenient, efficient processing that we will see next time. That's called polymorphism in the next video. Okay, but my students would get here together for a lab to practice some inheritance before we get to polymorphism, frankly. And I'd go into the lecture code, chapter 15. There's a folder called pass-fail activity, and that folder has 3 classes. It's got the graded activity, it's got the pass-fail activity, and then it's got the grandchild class, pass-fail exam. And I would ask my students to put this together in a project in Dev C++, read the specifications, and write a test driver that tests each of these separate classes and make sure we understand how to create one of them with a constructor, what functions are available in each of those classes, and test all the different functions and all the different objects. So I think that's pretty good practice. And again, when we come back next time, the next video, is maybe the single biggest idea in object-oriented programming called polymorphism, where if you have set up a class hierarchy like this, the redefined functions, you can have like one single function that accepts any one of these different types of objects and calls the correct function, the correct member function for each if they've been redefined. Super powerful, and it lets you write just one single function that actually accepts and operates on a wide variety of objects. And that's really efficient and really saves you a lot of time in programming. It gives you, again, a lot of power and a lot of flexibility. So if you know about inheritance, I really hope you'll join me for that, and I'll see you next time.